Welcome. This tutorial will guide you to properly connect and configure a strain gauge load cell with HBK MX, 1615B and 840B data acquisition systems. Let's get started. Step 1. Before handling any hardware, always review your load cell's specific calibration certificate or datasheet. Make sure to note down critical parameters like its maximum rated capacity along with its exact electrical sensitivity, recommended excitation voltage, and internal bridge resistance, which is typically around 350 ohms. Step 2. Check your load cell's wire color codes to identify their electrical functions. In this standard 6-wire configuration, blue and black handle the positive and negative excitation lines to power the bridge. Green and gray serve as the positive and negative sense lines, which let the DAQ automatically compensate for any signal loss over long cables. Finally, white and red transmit the positive and negative measurement output signals. Step 3. Once you know your wire colors, consult the official HBK hardware manual to reference the correct full bridge wiring schematic. Take a moment to confirm precise pin allocations for excitation, measurement signal, and sensing lines. Step 4. Connection with DAQ connectors. If you are using the MX 1615B module, insert the core leads directly into its 8-pin push-in connector as shown here. White goes to pin 6, red to pin 7, blue to pin 2, black to pin 4, green to pin 3, and gray to pin 5. Please note that if you are using a 4-wire sensor instead of a 6-wire version, you must physically install small jumper wires inside the plug between pins 2 and 3, and pins 4 and 5 to prevent a sense line error. For the MX 840B module, terminate or solder the leads to a 15-pin D subconnector following this pinout. White to pin 5, red to pin 10, blue to pin 3, black to pin 2, green to pin 8, and gray to pin 7. Don't forget to short pin 4 and pin 9 together to complete the physical bridge configuration. Step 6. Initialize the DAQ hardware and catmanEasy software. Align and firmly plug the wired terminal connector into an available channel slot on your MX 1615B or MX 840B module. Power on the DAQ unit and launch the catmanEasy data acquisition software on your workstation. Ensure that the software establishes a stable communication link with the hardware module. Once the catmanEasy software is launched and project loads, locate the channel where your load cell is physically wired, in this case, channel 5. Right-click on it, select Rename, and change the label to Load Cell 50 kN. Now, let's configure the sensor specifications. Click on the Sensor Database tab at the top of the screen and navigate to Strain Gauge Transducers. Open the folder, right-click to copy the default SG Full Bridge Sensor Profile, and then paste it directly into your user folder under My Sensors to create a customizable profile. Rename this new sensor profile. Let's say, Load Cell 50 kN. Next, move over to the Transducer Characteristic settings to define how the electrical signal maps to physical force. Change the physical unit from the drop-down to kN. Set the nominal range value to 50. And input the precise sensitivity rating from your load cell's calibration sheet. Here, we will set it to 1.25 mV per volt. Switch to the Transducer Settings tab to verify the electrical configuration. Set the excitation voltage to 5 volts, and confirm that 6-wire mode is selected for lead wire compensation. Once checked, click Update Sensor to save the changes. Return to the main DAQ Channels tab. In the right-hand search panel under My Sensors, search for your newly created profile. Double-click or drag it to assign it directly to Channel 5. With the sensor assigned, look at the live reading column. To clear any residual baseline offset, click the Zero Balance button at the top. The live reading will adjust to 0 kN. Your sensor is now properly configured for load data recording during testing. If this quick guide helps you get set up, hit the like button and subscribe for more instrumentation and testing tutorials.